Perpetuities. Let's start off with the definition of perpetuities. Now, first of all, let's have a look at what it says here, and I'll try and explain it to you. What you need to remember is that a perpetuity is a type of an annuity. So they're similar in that way, but you'll see the difference between the two. So in an annuity, you will earn interest after every compounding period. If the payment received after each compounding period is smaller than the interest, the annuity will continue to grow. So for example, if you remember the previous question, when we had Reza taking out, he had invested 12,000 and was receiving a payment of 20.35 per month. The interest he got in the first month was $60, wasn't it? So that interest is smaller than what he was receiving. So you can see that the annuity at the time was reducing at a rate. So that means it's going to eventually get zero because he's paying it all out all the time. So that's what you've got to notice, the difference between annuity and perpetuity. And if the payment received after each compounding period is larger than the interest, then the annuity will decay until nothing is left, exactly as that situation was. Okay, so when does the annuity grow? It grows when the interest is higher than the payment received. In that situation where Reza was, it wasn't. Now, if the payment received is exactly the same as the interest earned, in one compounding period, the annuity will maintain its value indefinitely. So, for example, if you're receiving, if you invested $12,000 and you are receiving, let's say, for example, $200 every month for the life of the, and that's what you were getting. You were just getting the interest only. You're still going to have $12,000 left. So this doesn't disintegrate. That's the difference. So this type of annuity is called a perpetuity. Payments of the same amount as the interest earned can be made in a perpetuity forever, and that's what happens. So that money stays and doesn't disintegrate. But you'll see that more when we start doing questions anyway. So let's have a look at the formulas that we're going to use for this type of question. So let VO be the initial value of the annuity for the perpetuity. So VO could be whatever, that's the dollar sign. Let R be the interest rate, that's still the same. Let D be the payment received. Now you can see payment received is going to be just the interest earned. So you put $1 million in at 10% per year or 5%, whatever, you're going to just take the interest earned on that, and at the end of it, that's going to still be in your bank. So it looks like the flat rate interest formula, doesn't it? So in this situation, D equals R on 100 times the initial investment. Simple. Elizabeth invests her superannuation payout of $500,000 into a perpetuity that will provide a monthly income without using any of the initial investment. So her initial investment will remain. All she's going to do is earn the interest on that money. So the question, if the interest rate for the perpetuity is 6% per annum, what monthly payment will Elizabeth receive? That's easy. So we're looking at a rate of 6% with an initial investment of $500,000, so that's $500,000. Like that. We just got to find out how much he's going to earn per month and then per year. So that's the simple part, isn't it? So the annual interest is 6%. We're going to get a monthly payment, so it's going to be 6 divided by 12. So the monthly interest is 0.5% every month she's going to earn on her initial investment. So we guys know that D equals R on 100 times VO. Our interest rate for the month, by the way, is just this, 0.5 divided by 100 times $500,000. You do that and you get your answer as $2,500. So if she put into that the annuity as a perpetuity, so she's this type of annuity is a perpetuity because she's going to still have $500,000 at the end of it. She invests into a perpetuity at 0.5% every month. She will earn $2,500 every single month for the whole year, for 12 months, because it's in there. And at the end of the year, there still will be $500,000 left over. That's a perpetuity. makes sense. Next one, how much money will need to be invested into a perpetuity account, earning interest of 4.2% per annum, again compounding monthly, if $200 was to be withdrawn every month. So our initial investment here, VO, equals, we don't know because that's what they're asking for, aren't they? And then we know that the interest rate is going to be 4.2%, that's per annum, so we've got to divide that by 12, and that works out to be 0.35% per month. That's the monthly figure. We divided it by 12 here for to get that yearly figure. So the yearly figure was 4.2. Sorry, divided by 12 gives you the monthly figure, but that's the per annum figure there. The amount withdrawn each month is 200. So we know that D is 200 at the moment. So you can use menu algebra solve on your graphics calculator for this. So in your solver, you can do menu algebra solve. 200 equals 0.0035 because that's that divided by 100. It has a percent there, so we've got to put it as a decimal for the calculator. And then you put that times VO, like that. And but you won't put VO into the calculator, you can just put X if you like. Times X, comma X, and then close bracket, enter. And then that will spit out for you what your X value is or your initial investment is, and you'll know that it'll spit out for you $57,142.867. And the question asks you, write your answer to the nearest dollar. So to the nearest dollar, that would be $57,143 that she needs to invest in order to get the payment of 200. So that's another example. Let's have a go at doing this question on the graphics calculator. A university mathematics faculty has $30,000 to invest. It intends to award an annual mathematics prize of $1,500 with the interest earned from investing this money in a perpetuity. What is the minimum interest rate that will allow this prize to be awarded indefinitely? So what they're going to do here is keep the 30 grand and just every year provide the winning money of $1,500. So they want us to work out what the interest rate would be. So let's have a look at this. So at the moment we've got $30,000 to invest. So the present value that we need to invest is $30,000. And why am I putting a negative? Guys, because it's got to go into the bank, doesn't it? That's got to go into the bank, and that's why that's at negative 30,000. Now we need to find out the interest rate. So that's the unknown so far. It's for 1 year at the moment. So let's go and put 1 into here like that. We want a payment. What's the payment going to be? We're going to give that. So we've got to withdraw it from the bank and give it to somebody else. So that's going to be a positive $1,500 that goes in there. So we put $1,500 in that situation. Backspace. Like that. So that's your $1,500 goes in there. The future value, we're still going to have 30,000 as our future value. So that's going to be a positive because we need that as coming to us. And it changed it because I pressed enter, so I shouldn't have done that. So we know that that's going to be 30,000. Put that in there. 30,000. I want to go down to that, and that has to be 1 and 1 because it's for 1 year. And then we need to work out the interest rate, which is this is what we need to find out right there, and press enter on this one. Press enter, and we see that it's 5%. So we know that if the university wants to invest $30,000 and give $1,500 to a student, the interest rate has to be 5%, and that's how you do that on the graphics calculator. Now, if we were doing this by hand, guys, all it would be, you can do menu algebra solve, don't forget, for this type of question, because all you would have to do in the graphics calculator is to type in menu algebra solve, 1,500 equals R divided by 100 times 30,000, comma R, close brackets, enter, and it'll give you the answer of 5%. So there's two ways to do it this way. The easiest would be to just do it through the finance solver. So please have a go at doing now 9F.